Hi everyone. Today we're going to learn the implementation details about TCP and UDP communications between client and server. So we're going to build client programs and server programs and run them to talk each other. Before we go further, I wanted to recall the concept of the protocols that we learned last week, TCP and UDP. And TCP is a connection-based communication, and UDP is a connectionless communication. Um, literally, it is defined that way. The implementation, the real coding, accordingly uh, implemented differently. So uh, some of the recordings have been posted below. So I want you to follow. If you are working on the platform of Mac um, operating systems, then you need to check out uh, the proper video clips. Likewise, if you are working on Windows operating systems, you can also follow uh, the different video clips. Both video clips, anyway, build client and server. And we need to first start the server program. Um, and then you can start the client, because the server is waiting and listening to communicate with the client. So, so on client program, you can talk to the server. Then server may respond it. Uh, so you can practice that, and also um, the similar things can be done over different devices, um, not only on the same platform, but you can build the TCP server on separate Linux operating systems or Mac OS. Meanwhile, you can also run the client on your Windows operating systems. By the way, Windows operating systems cannot run the server programs. One of the assumptions for them to talk between the server and client, the server program should have either a static IP address, or both client and server programs should be running under the same router. If they are under the same router, which is on the same subnet, then they can identify which one is what. So um, the IP address can be resolved um, straightforward. If you want to make a static IP for your server program, then you need to buy it. It is very expensive, so you don't need to. But you can practice it under the same router. So I want you to follow that and check out uh, the video clips. And this last one is for a little more practical, because we are talking about server and client. For one server, there should be multiple client. So client should not hold the communication by itself only, but we need to share, right? So how can we make it? So we're going to learn it, all right? So, so implementation details for that, we need to think the protocols. Are we going to build our client and server running over TCP or UDP? In this, well, as we did, yeah, both the TCP and UDP, and also on different platforms. That's what we did. So I want you to check out the video clips. But for this ones, as an example, we focus on TCP, because TCP is connection oriented. This is a little more complicated, so we will learn that. And also communications, one string of communication at a time. That works for the programs that we learned and we practiced so far. But what if we want to interleaving communication? What that means is that because we have one server, if we have multiple client, client can talk to, while one connection is established to one the client, there should be another connection to be established for another client and another connection for another client. One connection per client. We could have multiple clients, and each of those clients can talk to the server as if that client can talk to the server directly at any time. What that means is that the client should not wait until the other client complete their connection. And if that connection is disconnected, then now it is my turn, and I can hold my connection until I complete it, while many other clients are still waiting behind. That is a single threading. If you want to make multi-threading, then because we make multi-different the strings of communications, each client can talk to the same server at any time as if it is communicating in dedicated way. This is some of the program that we have done, typically as discussed in the past classes. So we build the server. The way that we build the server for TCP protocol, we need to create a socket objects and then bind this socket to a particular IP and port number. And then we can listen. This server needs to listen. We can open up one client. We can open up 5 clients. We can open up 25 clients, depending upon the capabilities of our hardware. And then we have a loop. In this loop, we accept a connection and receiving and sending data continually. So for example, if one client create a socket and try to connect, then this server accepts that connection. And then between this client and this server, sharing data by sending and receiving data. Even if the other client create sockets and try to connect, it maybe connects, but it's not currently. Connection is now, because this is connection oriented. So this guy, because it's one single thread is only one available. The client 2 needs to wait. Likely client 3 needs to wait until this connection is complete. Then next connection is activated, and therefore data sharing is possible. This is about single threading. So what it does is that if single thread, only one thread, if there is one connection, that connection needs to be complete, and another connection comes, and that should be complete and disconnected that connection, and then a new connection is established, and then it goes, because it has only one thread. If we have a multi-thread, then we still have the same code, same data, same file, but only difference here is that we have different sets of registers and stacks. Different registration and stacks. We have separate threads. For the same code, same data, we can have multiple threads. So this can work with the client 1. This thread work with the client 2. This thread work with the client 3. Remember that we learned multiprocessing in operating systems, right? Between this multi-thread and multiprocessing is that, as clearly displayed on this slide, multi-threads established for the same code, same data, same files. Multiprocessing, if we have two different, more than one code data file sets, then still we can make it one single thread like this, right? But in this case, single process, But in the last case here, we could have a multiple process. So one process take care of data, code files, register, and stacks. And the other process take care of different code, different data, and files, register, and stacks. We could have more than one process. Today, what we are going to look at is this, multi-threading. We're not considering the multiple processes for the one single processing, but multi-threading. This could be done only by code. By running the same code, we can do this, multi-threading. So how it works. We need to have a thread object created. Okay, thread object is created per connection. All right, so it is not only one code per connection, but thread object is per connection, and then that thread starts. So in the same way that we create a socket objects binding to IP and port numbers and listening, we accepting connection, then we make a threads. Another connection, then we make another thread. For another connection, we make another threads. For each thread can talk to each different client. This thread talk to client 1. This thread talk to client 2. This thread talk to client 3. So this guy is send and receiving. If this guy still send immediately, then before this guy responding, this guy can receive it. So lots of interleavings possible in this case. So without further ado, we're going to practice it. This is a typical program. So this is a single thread, and this is the TCP server and client, but in single threads. How can we learn? How can we run? How can we execute them? Then we need to turn on the terminal. We need to make another terminal. Shell basic. I want to do two client and one server. Okay. This guy is, let's see, where is this guy is running right now? That I need to find out. I believe that he's in, give me a second. That is here. So I'm going to, this is a TCP single thread PY. So find out the location. So this is the location. I get the path name. Close this and move this away. And what I want to do is I want to do a CD and to that place. I want to make this CD. Change directory. Okay, I have that. Let's make sure that I have that. Okay, I have that. All right, this is a server, so I am running TCP single thread. So TCP is now threading, and this guy, what I want to run is TCP client. TCP class client, Python TCP class client.py. I'm running that, and also I want to do this guy quickly got connected by 127. They are running all the same host, right? We call that local host, and IP is 127.0.0.1, port number 56471. So if I want to do similar things, Python TCP class client, same one. Then this guy didn't respond yet, although I connect, because this is a single thread. So one thread is already held by this client. So if this guy says, what do you want to say? So we can say, hello, my server. Then it says, here received, hello, my server, from this guy, right? And then what do you want to reply back to this client? port number 56471. That is this guy, right? So I can say I am good. 56471. I'm good. 56471. And then that message responded to this guy 57471, right? Keep doing this. Although even if this guy says hello port server, although this guy says, because it's a single thread, still that thread is held by this guy. So in this case, this guy says I'm good. So this guy says I gotta go. Bye. I gotta go. Bye. I gotta go. Simply, I gotta go. Then still that single thread is held by the same connection, D1 connection. So that's still from the same port number, right? What do you want to do? Then it guys says okay. Then okay came here, and then I want to say end. What do you want to say? End to quit. So I say end. So I put here end. It says end. What do you want to say? I want to say, let's say dash dash. Then dash dash. And then this is disconnected. After this is disconnected, then here now connected by 56472. So far what we did is 56471, which is this guy. But this guy, connection is stopped. Now that is connected by this, right? So originally this guy says hello host server. Finally that message came up because this server now by the single thread, by that thread connection is established for these port numbers, right? So it says hello host server, and then this guy says fine and new. Now that come over here, right? Fine and new, and this guy says end, and this guy says okay, and that is disconnected, and that is still waiting for some others, right? That is end. If you see this code, if there is no further messages comes out, then that is ended. So if we don't wait until this guy make that decision, we need to interrupt it by holding down control button for Windows or command button for Mac OS, and C for Charlie. Let's see. Oops. I think it's Control C only. Yeah, Control C. So it is gone. Now, for the same ones, I want to run by this guy, okay? TCP multi-threadings. So what I want to do is, rather than this, TCP multi-threading PY. So that is, so server is now waiting. If you see this code itself, I'm not going to explain this code much because you guys do not know yet how you can make a multi-threading in Python. But I can point out here, for one connection, we need to create a thread object. So threading.thread. There's a thread object, and that object starts. That's what it is. Okay, this is a server side. So server has done that. For client doesn't matter. For the same client, I can do this. For the same client, I can do this. See here, I just connected from two different clients. This server can respond for the two different clients, right? Because this is multi-threading. This thread talk to that guy at the same time, not really at the same time, but in multi-threading, this guy responds to a different connection. So if here in this case says hello from, we can say this is a second, okay, and then this is a first. If I do this second, this guy already responded. And then you can say, hello from first. Still that is hello from second, and here hello from first, right? Still respond. And if I want to say here, what do you want to say? Because I received this guy from the second. So if I say, hey, this might come to second. So that comes to second, right? And then this guy already asked this guy, right? So that I can say, this might go to first. See, that goes to first. So this multi-threading program can talk to simultaneously more than one connections. Okay, that is a multi-threading. That's what I want to say to you in this video clips. Hope you can understand how it works. Okay, you don't need to worry about this, the coding itself, but how they behaves. All right. When I quit from the first, so if I do end, then this guy already knows end. If I do end here again, then this guy already say that. Okay, then this guy stop the communication. If I do okay, then this guy again stop the connection. All right, this is it. Bye.